Good day everyone! Welcome to Math with Teacher Justin. On today's topic, we're going to talk about special right triangles, which is the 45, 45, 90 triangle or the isosceles right triangle.
Okay, let's talk about the special right triangle wherein we have an isosceles right triangle. So take note that the measurement of our isosceles right triangle will be a 45, 45, 90 triangle. So in an isosceles right triangle, the length of the hypotenuse is square root of 2 times the length of any of its leg. So here is an example of an isosceles right triangle with a 45, 45, 90 angle. And here is an example. So if we have 1 as the measurement of each leg, okay, to get the hypotenuse, we will just multiply 1 by square root of 2. Alright, so let's test this theorem with an example. Alright, okay, so let's try this example. So for example, we have this triangle. We have a 45, 45, 90 wherein the legs is 4 units. So we're looking for the hypotenuse. So in this special right triangle, we will use the theorem that the length of the hypotenuse is square root of 2 times the length of any of its leg. So we will just have this equation, C, our hypotenuse, is equal to x times the square root of 2. X is our measurement of each leg. So substituting, we will have C is equal to 4 square root of 2, which is the measurement of our hypotenuse, which is C is equal to 4 square root of 2. Alright, okay, so let's have another example. So for this example, we have 10 as our measurement of one of the legs, and we have a 45, 45, 90 special right triangle. So we're going to compute for the measurement of our hypotenuse. Now using the theorem, in a 45, 45, 90 triangle, we will have the length of the hypotenuse is square root of 2 times the length of any of its legs. So we will use this equation, C is equal to x square root of 2. Then we substitute the measurement of the leg. So we have the hypotenuse is equal to 10 times square root of 10, which is the measurement of our hypotenuse, 10 square root of 2. Alright, okay, let's have another example. So for example, we have a special right triangle, 45, 45, 90, and we're given one of its leg. So since we have congruent legs, okay, we have 6 square root of 3 as our measurement for both legs. And we're going to look for the measurement of the hypotenuse. Now to get the measurement of the hypotenuse, no need for us to apply the Pythagorean theorem, but instead we will use the theorem about a 45, 45, 90 triangle. So the length of the hypotenuse is square root of 2 times the length of any of its leg. So we will use this equation. The hypotenuse is equal to the measurement of the leg times square root of 2. So let's substitute. We will have C is equal to 6 square root of 3 times square root of 2. Then let's apply the rules in multiplying radicals, wherein we multiply the coefficient by the coefficient, radical by radical. So this will be C is equal to 6 square root of 6. Alright, now let's have another example, but this time we are given the hypotenuse, the measurement of our hypotenuse. So we're going to look for the measurement of our leg. So since this is a special right triangle, a 45, 45 triangle, we will still use the theorem. The length of the hypotenuse is square root of 2 times the length of any of its leg. So we're going to use the formula or the equation, C is equal to x square root of 2, or the hypotenuse is equal to measurement of the leg times the square root of 2. So let's substitute our given. So we have 8 square root of 2 is equal to x square root of 2. Then we divide both sides by square root of 2. So to isolate our variable x, so we apply cancellation. We will have x is equal to 8. And that will be the measurement of each leg in this triangle. Okay, let's have another example. Again, given the hypotenuse, and we have a special right triangle, which is a 45, 45, 90 right triangle. We will solve for the measurement of the legs. So again, we will use a theorem about the 45, 45, 90 triangle. wherein the length of the hypotenuse is square root of 2 times the length of any of its leg. So, since we're given the hypotenuse, 16 square root of 2, we will still use this equation. C is equal to x square root of 2, and then substitute the given. So, let's substitute the given. 16 square root of 2 is equal to x square root of 2. Then let's divide both sides by square root of 2. And then apply cancellation to isolate the variable x. Therefore, the value of x will be equal to 16. Alright. Okay, let's have our last example for today. So, for example, we're still given the special right triangle of 45, 45, 90. And this time, we're given the measurement of our hypotenuse. So, since we are given a special right triangle of 45, 45, 90, we will use the theorem. The length of the hypotenuse is square root of 2 times the length of any of its leg. So, we will use the equation C is equal to x square root of 2. Let's substitute our given. So, we will have 10 is equal to x square root of 2. Now, let's divide both sides by square root of 2 to isolate the variable x. So, let's cancel. So, we will have x is equal to 10 over square root of 2. Now, take note that this will not be our final answer yet, because we need to apply rationalizing our denominator. So, to rationalize, we need to multiply both numerator and denominator by the square root of 2, so that we can eliminate the radical sign in our denominator. So, take note that square root of 2 times square root of 2 is, so we will have 10 square root of 2 over 2. And then let's simplify our coefficient. So 10 divided by 2, that is equal to 5. Therefore, the measurement of each leg will be x is equal to 5 square root of 2.
Now that you already know how to solve special right triangle, especially 45, 45, 90 triangle, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.